So today we'll discuss the concepts of the Newton's laws of motion, a very important chapter. In this chapter, you are going to deal about the two concepts. One is we are going to deal about the cause for the motion. In the previous chapters, we have studied only what is the displacement, velocity, acceleration, and all those things. Now, in this chapter, we are going to deal about the cause for the motion, and we are also going to talk about the opposing force, that is the frictional force. So these are the very two important concepts from the laws of motion. And in your exam, you are going to get around 12 marks in the board exam. But for the coming quarterly tests also, you can expect the one derivation and one 5-mark problem for the quarterly test. Now, suppose if I considered one inclined plane. If I considered an inclined plane, on this inclined plane, if I considered an object, if I drop this object here, this object start sliding down and it is moving, and in the horizontal surface also it will move, and it will move up on the another inclined plane here, and it will come back. So there will be a to and fro like this. But according to the Aristotle theory, in order to keep this object in motion, you have to apply a continuous force. You have to apply a continuous force. So a continuous force is required to keep this object in motion. This is what the Aristotle states. So what is the statement of the Aristotle? In order to keep the object in motion on this inclined plane, at every moment, at every point, you have to give a continuous force to keep this object in motion. This is the statement of the Aristotle. Later, the Newton has developed a concept. According to this Newton, no force is required to keep this object in motion. If you drop this object on the inclined plane, the object will start moving by its own, and there will be some internal force which keeps that object in continuous motion. No continuous force is required to keep the object in motion. That is the statement given by the Newton, and he has performed a various experiment to prove this. After giving this statement by the Newton, this statement which was given by the Aristotle becomes a Aristotle false statement, which is considered as a Aristotle fallacy. So initially, what is the Aristotle told about the concept of the motion of the particle? That is exactly reversed. Aristotle told a continuous force is required, but Newton proved that there is no continuous force is required to keep the object in motion. So that statement becomes a Aristotle fallacy. So what is the statement of the Aristotle fallacy? A continuous force is required to keep the object in motion. That is the statement given by the Aristotle, which is wrong statement. So it is considered as a Aristotle fallacy. Now, why the object is in continuous motion? If the object is in continuous motion means in this object, there is some inherent property. So if this object is continuously moving, if this object is continuously in motion, it is continuously in motion because of some inherent property present in the body. It is the inherent property present in the body. Or if I considered a table, on the table, if I place a object, this object will not change its position. So I can say the object is at rest. So if I place the body at the table, this object or body is continuously at rest. So there is an inherent property here also. Here also there is an inherent property. So a body can be continuously be at rest, or it is continuous in motion because of the inherent property present in the body. That inherent property we considered as inertia. So what is inertia, students? It is the inherent property of a body. Because of that property only, the body will be continuous in motion or the body will be at rest. This is what we considered as the inertia. If any body is not having this type of inherent property, the body can't be in continuous motion or it can't be in a continuously at rest. So such an inherent property is what we call as the inertia. We have classified this inertia into different categories or different types. One is called as the inertia of rest. Inertia of rest. Second one is called inertia of motion. The third one is called as the inertia of direction. So there will be three types of inertia, students. One is called as the inertia of rest. Second one is the inertia of motion. The third one is called as the inertia of direction. But anyway, we don't have the complete explanation of this, but try to remember the three types of inertia at least. That is inertia of rest, inertia of motion, and inertia of direction. And I think this is the very basic concept which you have studied in your high school, where the body, when it is at rest inside the bus, if bus suddenly starts, you going to be fall backward. Why? Because of inertia of rest. Similarly, when the moving bus applies the brake, you are going to fall forward because of the inertia of motion. Similarly, in the case of inertia of direction, you can see the mud particles which is coming out of the wheel. It is coming tangentially out. That is because of inertia of direction. Anyway, this is not there in detail about the concept of inertia. But you have to know what is inertia talks. So after analyzing this internal property of the body, that is inherent property of the body, which you considered as inertia, Newton is given the statement in three different laws. That is what we considered as the Newton's first law, Newton's second law, and the Newton's third law. So these are the three laws you have to analyze in detail now about the concept of the laws of motion. Students, suppose if I consider an object which is at rest, the object which is at rest. This object is at rest. Now, I want to change this body to motion. The body which is at rest, I have to change the inertia of that. I have to change from rest to motion. Suppose if I considered a particle which is moving, which is in motion, I have to bring this object to rest. I have to bring the object to rest. Rest to motion, motion to rest. In order to change this inertia from rest to motion, from motion to rest, in order to change this inertia, we required an external agency for this. We required an external agency for this. So an external agency is required to change the body from rest to motion or from motion to rest. So if the body is continuously at rest, now you, in order to change to motion, you require an external agency. Similarly, when the body is in continuous motion, the body can be brought to rest by using an external agency. That external agency is what we called as the force. So according to your Newton's first law, what is the statement of the Newton's first law, students? An external agency is required. An external agency is required to change the state of a body. To change the state of the body, an external agency is required. An external agency is required. That is what we call as the force. State of the body means we can take from rest to motion, or you can take it from motion to rest. In order to change this, you require an external agency. That is the statement of the first law. So actually the first law gives the explanation for the two parts. First thing, it will talk about the inertia. The second thing, it will talk about the concept of an external agency, that is the force. So if the body continues to be at rest or in a motion, that property is called inertia. In order to change that inertia, we require an external agency. What is that called? Force. This is what we considered as the statement of the Newton's first law. Any doubt, students?
No, sir.
Okay.
No, sir.
Now, let us take up the concept of the Newton's second law. But before going to the Newton's second law, let me know the momentum P. Let me know the momentum P. Suppose if I considered a body of mass, M, if I considered a body of mass M, if I apply an external force, to this body, what happens? The body starts moving from this position to this position. Whenever the object has moved from this point to this point, there will be some amount of motion is possessed. There is some total motion possessed. Total motion possessed by a body is what we called as the momentum. What is momentum, students? What is momentum?
To the motion possessed by the body.
Yeah. Suppose if the body has covered 10 meter, instead of 10 meter, if it covers 25 meter, then what happens? The total motion possessed by the body will be more. Correct? No? So how much of total motion is possessed by the body is what we called as the momentum. Is what we called as the momentum. And how this momentum is measured? This momentum is measured as the product of mass and velocity. How the momentum is measured?
Mass into velocity.
The momentum is measured as the product of mass and velocity. Yeah. What is the mathematical formula? M into V. Can you talk about the SI unit for this?
kg meter per second.
For mass, it is kg. For velocity, it is meter per second. This can also be actually written as Newton second. Newton second. Later we'll prove that. So what is the SI unit of momentum? Kg meter per second. Is it a scalar or a vector quantity, students?
Vector, sir.
Very good. It is a vector quantity that will act in the direction of the velocity because mass is a scalar. So momentum is going to act in the direction of the velocity. Can you tell me the dimensional formula? Can you tell me the dimensional formula?
M into L into T.
Not M into L into T. For kg, you will get mass, M, right? M power 1. For meter, you will get length, L power 1. For second, you will get time. That time is in the denominator, no? If you bring from denominator to numerator, -1. So what is the dimensional formula for momentum? M1, L1, T minus 1. So what is momentum actually, students? Momentum is the total motion possessed by a body. How it is measured? It is measured as the product of mass and velocity. That is given by the formula P vector equals M into V vector. What's the SI unit? Kg meter per second, or you can say Newton second. Is it a scalar or a vector quantity? Vector quantity. What about the dimensional formula? What about the dimensional formula? M1, L1, T minus 1. Okay. Now, very, very important, students, for 5 mark. State Newton's second law of motion. Hence derive F equals to m into A. State Newton's second law of motion. Hence derive F equals to m into A. Now, consider a scenario here like this. This is one particle. I am applying a less amount of force. I am applying a less amount of force. Because of this force, the body has taken this amount of motion. This is the motion possessed. Can you tell me what will happen if I increase this force? What will happen if I increase that force? It will possess more motion or less motion? It will possess less motion or more motion?
More motion, sir.
More motion. So, if you apply the more force, the more motion will be possessed. So, the total motion possessed is nothing but momentum, right? So, if you increase the force, the momentum is going to increase. So, clearly this clearly tells the rate of change of momentum is directly proportional to the force. Rate of change of momentum. Rate of change of momentum is directly proportional to what?
Force.
Is directly proportional to applied force and takes place in the direction of
Force applied.
is in the direction of what?
The force applied.
Is in the direction of the applied force. So rate of change of momentum is directly proportional to the applied force and takes place in the direction of force. And takes place in the direction of force. Can you tell me the mathematical form? Force is proportional to what? dP by dt. What is P? Momentum. So rate of change of momentum means dP by dt. This is the mathematical form of the force. Force is directly proportional to dP by dt. Now, how to derive this F is equal to ma, students? It's a very quite simple. You considered a particle of mass m moving with the initial velocity u. For this moving body, if you apply the external force, what will happen? The body will continue to move with higher velocity. Let us say that higher velocity is v. Higher velocity is v. Now, if you apply this force to change the velocity v, the body get accelerated. Can you tell me how the momentum is defined? Momentum is defined as the change in velocity, that is mv minus mu. After applying the force, the velocity has changed from u to v. So what is the change in the momentum? The change in the momentum is nothing but mv minus mu. Therefore, how do you define the force? Force is nothing but the rate of change in momentum. What is the change in momentum? mv minus mu. What is the time? Let us say t is the time taken. So F is equal to, if I take out m common, I'm going to get v minus u by t. What is v minus u by t, students? You know that the equation of the motion v is equal to u plus at, isn't it? So what is v minus u? A into t. So what is v minus u by t? A. So v minus u by t is nothing but a. So what is the force formula? Mass into acceleration. It's a very simple derivation. So first you have to consider a particle of mass m moving with velocity u. So that if you apply the force, the velocity changes to v. Then what is the change in the momentum? Change in momentum is nothing but mv minus mu. So what is the rate of change of momentum? It is mv minus mu by t. That is nothing but the force F. So take out m common, you will get v minus u by t. From the equation of motion, you can prove that v minus u by t equals to a. Therefore, force is equal to mass into acceleration. So this is how we are going to derive the equation of the Newton's second law. Yes, any doubt in this derivation, students? If you have any doubt, please feel free to ask the doubts. Let us have a discussion session. If you have any doubt, please let me know. Okay. Let us make a note here, students. Actually, Newton's second law is given by force is equal to mass into acceleration. But this formula is valid only mass is constant. This formula is valid only if the mass is constant. If mass keeps on changing, what will happen? If mass changes continuously, then force is given by m into a plus additional parameter is there, students, that is v into dm by dt. Please remember this. So what is the general formula for the Newton's second law? F is equal to m into a plus additional term is there, that is v into dm by dt. This is called a variable mass, dm by dt. Suppose if mass is not changing, there will be no change in the mass. So this term will be 0. So 0 into v will be 0. You will get back that F is equal to ma. So if the mass is changing, if mass is variable, then the formula for the force is given by m into a plus v into dm by dt. Usually this we are going to use it only in MCQs, not for your board exams. Not for your board exams. So what is the formula for the force, students? Mass into acceleration. Okay. Now, let me know what is impulsive force. What is an impulsive force? Student, if I consider a football here, if I kick this football, I'm giving large force or a small force?
Large force, sir.
We are applying a very large force. Good. We are applying a very large force. And you can notice here, you can't give the continuously the large force. You have to give that large force only for the short time. You have to give the large force only for short interval of time. For short interval of time, you are applying a large force. That is what you considered as the impulsive force. So what is an impulsive force? Impulsive force is the large force which is acting for short interval of time, kicking a football. When large amount of force is acting for short interval of time, that force is what we called as the impulsive force. Sir, how to measure that? That is going to be measured by a parameter called impulse. How it is measured impulse? Impulse is measured as the product of the force and the time. How the impulse is measured, students? Impulse is measured as the product of the force and the time. What is the force formula? Mass into acceleration into the time. So impulse is measured as the product of the force and the time. So impulse is equal to mass into acceleration into time. So I is equal to m into, you know that the acceleration is change in velocity by time into the time. So this t and t will get cancelled out. So impulse is equal to m into v minus u. I is equal to m into v minus u. If I multiply m inside, it will be mv minus mu. Mv minus mu. Or I can say impulse is equal to, this is final momentum, students, mv. Mu is initial momentum pi. Final momentum minus initial momentum is nothing but delta p. This delta p tells the change in momentum. Delta p tells what? The change in momentum. So the change in momentum is nothing but I. What is that I called? Impulse. So here clearly you can prove that impulse is nothing but the change in momentum. Impulse is nothing but what? The change in momentum. How the impulse is measured? Force into time. So only I can write F into T as the change in momentum. What is the unit you have said for momentum? kg meter per second. What is the unit for impulse? What is the unit for impulse?
Newton second.
Very good. Newton second. Newton second. So only I've told kg meter per second and Newton second are same. So what is the unit for the momentum? Either you can tell Newton second or kg meter per second. They may ask this derivation for 3 marks, students. 3 marks. To show that the impulse is equal to the change in momentum. Show that the impulse is equal to what? Impulse is equal to the change in momentum. Impulse is equal to the change in momentum. Okay. Let me have this discussion here. Now, there is a wall. I'm considering a ball which is moving in this direction with velocity u. Mass of this ball is u. Now the ball is going to rebound back. The ball is going to rebound back, let us say with same velocity u. Can you tell me what is the change in momentum for this case? What is the change in momentum, students, for this case? Okay, tell me at least what is the change in momentum? Final momentum minus initial momentum, no. What is final momentum? Mass into final velocity u minus what is initial momentum? M into this velocity u. But look at the direction, students. Don't tell it is 0. Look at the direction. This u is going with a positive x-axis. After rebounding, it has changed the direction, isn't it? So it becomes negative x-axis. So this final velocity will become minus u because it is opposite to the initial one. So this is equal to minus mu minus mu. Therefore, this is equal to minus 2 times of mu. This is what the change in momentum. So what is the change in momentum when the ball strikes the wall horizontally? When the ball strikes the wall horizontally, the change in momentum is minus 2 times of m into u. Yes, Padapat, let me take one more simple example. This is wall, students. Now this is the ball which is thrown like this. Mass is m with velocity u. This ball is thrown at exact angle theta. Now the ball is going to rebound like this with the same angle theta with same velocity u. With same velocity u. Now, can you tell me what is the change in momentum here? What is the change in momentum? You have to be very careful. You have to split this u into 2 components. This is one component. Vertical is 1. So this is u sine theta. This is u cos theta. Similarly, you can split this u into 2 components. This is u sine theta, isn't it? In the last session, we have discussed this. this will be u cos theta. So with the component which makes an angle theta, that will go with cos. The other one will go with sine. Now, how u sin theta and u sin theta are acting? They are acting in the opposite direction. So this two will get cancelled out. This two will get cancelled out. So only the left out is u cos theta, u cos theta. So the change in momentum will be 2u cos theta into mass. Mass into velocity. Sir, why you are writing 2u cos theta? Because u cos theta are acting in the same direction. So you just add up that. So this delta P becomes 2 times of mu cos theta. So what is the change in momentum? 2 times of mu cos theta. If you refer this as the negative x-axis, you can treat this as minus also, no doubt about that. So this is how the change in momentum we are calculating in the case of a inclined plane, students.
Excuse me, sir.
Yeah.
Sir, can you tell me how u sin theta and u sin theta got cancelled?
One u sin theta is acting along the positive y-axis, isn't it?
Yes, sir.
The another u sin theta is acting in.
Negative y-axis.
So if one force is acting, if one force is acting in the upward direction and another force is acting in the downward direction, what will be the resultant for this?
0.
Yeah, minus this. So u sin theta minus u sin theta, that will cancel out, no?
Okay, sir, I understand.
But that is not happening with u cos theta, because u cos theta are in the
Same direction.
they are in the same direction. Good. So we are adding that. So u cos theta plus u cos theta, it becomes 2u cos theta. Got it? Yeah.
Yes, sir.
Okay. Now we'll go to the next concept. That is the Newton's third law of motion. I think you are very familiar with this Newton's third law of motion. What's the statement? For every action, there is an equivalent opposite reaction, isn't it? Talking about the Newton's, we are talking about the Newton's third law of motion. That is, for every action, there is an equal and opposite reaction. And this reaction and reaction should act on the two different bodies, students. If action is acting on the first body, reaction should act on the second body. Both action and reaction cannot be on the same thing. Suppose if I considered a body A here, and I'm going to consider a body B here. So how much of force is going to act on the body B? Let it be an action. The same amount of force is given to the body A by the body B. That is called the reaction. Now what I'm saying, the force acting on the body B due to A is equal and opposite to that of A to the body B. Force acting on B due to A must be equal to minus force acting on A due to body B. So this is according to your Newton's third law of motion. Now, if I multiply by t on both the side, if I multiply the time on both the side, what happens? Force acting on body B by the body A into t is equal to minus force acting on the body A to the body B into t. What is force into time, students? What is force into time?
Impulse.
Good, impulse. So this is the force acting on body B, isn't it? So this should be the impulse of the body B. Minus, this is the force acting on body A. So this should be the impulse on body A. And also you have proved that the impulse is equal to what?
Change in momentum.
Change in momentum. So the final momentum of the body B, let it be P dash minus P2. P2 dash is the final momentum. P2 is the initial momentum of the body B. So P2 dash minus P2 is equal to minus. What is the impulse of A? Change in momentum, let it be P1 dash minus P1. P1 dash is the final momentum of the body A. P1 is the initial momentum of the body A. So P1, P2 dash minus P2 is equal to minus P1 dash plus P1. So P2 dash, I will shift minus P1 dash to that side. It will become P1 dash. This will be equal to P1 plus P2. So what is P1 and P2? P1 plus P2? If I say this is the body A, this is the body B, these two are moving initially with momentum P1 and P2. After collision, the first body is moving with momentum P1 dash. The second body is moving with the momentum P2 dash. So before collision, what is the total momentum? Before collision, what is the total momentum? P1 plus P2. What is P1 plus P2? Total momentum before collision.
Total.
What is P2 dash plus P1 dash? Total momentum after collision. So what I can say here, whatever the total momentum is there before collision, the same momentum we have even after the collision. Even after the collision. So what it indicates? Momentum is neither created, it is not to be destroyed. Momentum is neither created nor to be destroyed. This is what we called as the conservation of momentum. Conservation of what? Momentum. So very, very important question, students. They will ask you to state and prove. They will ask you to state and prove law of conservation of momentum. State and prove the law of conservation of momentum. What's the statement of the momentum, students? You can tell the total momentum remains constant when no external force is acting. When no external force acts. If the external force is not acting, you can tell the total momentum always remains constant. So that is clearly tells momentum is neither created nor to be destroyed. The momentum is neither to be created nor to be destroyed. Now, if I considered an object of mass m1, let us say body A, moving with initial velocity u1, the momentum is p1. Similarly, you have to consider the second body, right? What is the second body mass? Let us say the second body mass is m2b, momentum is p2, moving with what velocity? u2. Students, if these two bodies collide for a moment t seconds, then the first body is going to move with the velocity. The first body is going to move with the velocity v1. The second body of mass m2 is moving with the velocity v2. Let us say P1 dash is the momentum of the body A after collision. P2 dash is the momentum of the second body after collision. Now, according to your third law of motion, when these two bodies are going to collide, you can tell the force acting on the body A to the body B, force acting on the body B by the body A must be equal and opposite. So I can write FAB vector is equal to minus FBA vector. This can also be multiplied by time on both the side. Minus FBA into T. Force into time is nothing but impulse. This is the force acting on the body A. So impulse is nothing but the change in momentum. This is the force acting on A. So I can take P1 dash minus P1 is the change in momentum of A minus of, this is the force acting on B. So I can take P2 dash minus P2, that is the change in the momentum of the second body. So P1 dash minus P1 equals minus P2 dash plus P2. On shifting the terms, I can write P1 dash plus P2 dash is equal to P1 plus P2. So this is the total momentum after collision. This is the total momentum before collision. So the total momentum before collision and the total momentum after collision are equal. So you can tell the total momentum remains constant. A very, very, very important question, students. They may ask you to state and prove law of conservation of momentum for 5 marks. It's a short question. Probably they may ask this only for your coming quarterly test. So this is how we are going to analyze the concept of the Newton's third law of motion. Yeah. Yes, let me have a common forces. What is the common forces we are usually using in the mechanics? Now, if I considered a surface, on the surface, if I place an object of mass m, here the downward force will be there. The downward force, usually we call it as weight. That weight is going to be considered as m into g. What is the weight, students? M into g. So what is the first common force we are talking? We are talking about the weight. Weight always going to be act downward, which is given by the formula W is equal to m into g. Now, because of this support, because of this surface, this is not moving down. This body is going to get balanced by another force which is going to act perpendicular to that surface, that is denoted with N. That N is called as the normal reaction. So what is the second common force we are talking? We are going to talk about the second thing, that is normal reaction. So the first one is weight. The second one is the normal reaction. Let me know what is the third one. Now, I'm going to consider one rigid support here. From this rigid support, I'm going to suspend one thread. Other end of the thread is going to be connected to some bob having mass m. No doubt, the weight is going to act downward. The weight is going to act downward, that is nothing but mg. But student, here the normal reaction will not come into picture. Why normal reaction will not come into picture? Because the object is not connected with the surface. This is hanging over by the help of the thread. Then there will be some upward force is going to act on the thread. That upward force is called as the tension T. What is that upward force called? Tension T. So we are talking about weight, the normal reaction, and the tension. In this case, normal reaction is equal to mg. In this case, tension is equal to mg. So what are the common forces we are talking, students? One is weight. The second one is normal reaction. The third one is about the tension. Now, if I say mg is more than the tension, in this case, the body will move downward. The body will try to move downward. If tension is acting more than mg, then the body will try to move upward. If the body is not moving, means the tension should be balanced with mg. The normal reaction should be balanced with mg. So what are the common forces we are talking, students? One is weight. The second one is called the normal reaction. The third one is called the tension. Okay. Now, let me explain this one more example. Usually this is also important, but usually we are going to solve this in MCQs. I'm going to consider one pulley over here. I'm considering the pulley. Suppose if I considered one object here of mass m1, there is one more object I'm going to connect over here, that is m2. I'm talking, this is connecting body, students. Now, can you write the common forces here? Here, what is the downward force? M1G. What is the downward force here?
M2G.
M2G. Between M1 and M2, one thread is passing. So the tension is going to act over here. Let us say the tension is T. What is the tension is acting? T. So if the tension is M1G and the tension is equal to M2G, the body will not move up and down. The body will be in equilibrium. The body will be at rest. Assume the second body mass is heavy, so that this M2 is coming down with some acceleration A, and M1 is moving up with an acceleration A. Now, shall we write the equations now? Equations for the body A. For body A, since it is moving upward, T should be more or M1G should be more? Tension should be more, good. So shall I write T minus M1G? Because these two forces are in the opposite direction. So T minus M1G is equal to force, that is M1 into A. Now, can you tell me equation for B? This is B. For B, it is coming down. If it is coming down, means M2G minus T is equal to what? M2 into A. You can add these two equations, students. If you add this 1 and 2, what you will get? Plus T minus T will get cancelled out. You will get M2G minus M1G is equal to M1A plus M2A. What is common here? A is common, that is M1 plus M2. Here G is common, so it becomes M2 minus M1 into G. Can you tell what is A for this? M2 minus M1 divided by M1 plus M2 into G. So what is the acceleration of this system, students? M2 minus M1 divided by M1 plus M2 into G. This is the acceleration of the system. Let me talk about the correcting bodies later, students, because if for theory they won't ask much about the connecting bodies, this one example is sufficient for you to better understanding of the tension and this G. Now, let me talk about the apparent weight in the case of a lift. Apparent weight in the case of a lift. Definitely they will put a 1 mark question on this. Now let us consider a lift. Let me consider the 3 cases. Even if you want, let me consider one more special case also. So let me consider the 4 different cases. Now, inside the lift, let us say there is a person of actual mass is m. Inside the lift, there is actual mass. Inside the lift, there is a person of actual mass m. Now, can you tell me, students, in which direction the weight of that person is going to act?
Downwards.
Weight of the person is going to act downward. That is mg. Okay. Now, I'm going to say that the lift is at rest in the first case. The lift is at rest. If lift is at rest, the weight will not change anything. So the actual weight W dash will be W only. That is equal to what? Mg. There is no change in the weight when the lift is at rest. Second case, I'm taking the lift upward. I'm taking the lift upward with some acceleration, let us say A. Students, if the lift is acted upon upward with some acceleration A, will the person will move upward along with the lift?
No, sir.
The person will stay at rest only. The lift is taking up. So some additional force is acting on the body to balance this additional acceleration. So what is that additional force? MA. So additional force is acting on the body to balance this. So your actual weight M dash is W dash is actual weight mg. Addition to that, there is some extra forces acting, that is MA, to balance this. Actually, this is called a pseudo force. Namu gottirala force ado. So there is a pseudo force. Extra force is acting on the body to balance that. That extra force, which is not visible, that is called the pseudo force. So pseudo force is just balancing that. So here clearly you can see here, when the lift is moving upward, apparent weight will become actual weight plus MA. So additional weight is there. So what is your conclusion, students? Apparent weight will increases when the lift is moving. Upwards. Now, can you tell me if the lift is moving downward with acceleration A? The lift will come down, but the body will not come down. It will stay as it is inside the lift. So some additional force is acting in the upward direction to balance this. What is this additional force called? Pseudo force. Here it is acting in the upward direction. So what is the apparent weight here? The actual weight is mg. For that, there is minus MA. Mg minus MA. So here the apparent weight is decreases. So the apparent weight decreases when the lift is moving downward. The apparent weight increases if the lift is moving upward. The last case, if the lift is coming down under gravity, A is equal to G. The chain of the lift is cut, so it is falling under gravity. So what happens to double dash? Mg minus Mg. So W dash will be 0. So this tells that the body is weightlessness. So when the body feels weightlessness, if the lift is falling under gravity. So these are the different 4 cases, students. They may put the question in MCQs or in the fill in the blanks. What happens to the apparent weight when the lift is at rest, if it is moving upward, if it is moving downward, and if the lift is falling under gravity. So if the lift is at rest, no change in the apparent weight. If the lift is moving upward, apparent weight will be more than the actual weight. If the lift is coming downward, apparent weight will be less than the actual weight. If the lift is falling under the gravity, then the body feels weightlessness. So this is the concept of the apparent weight in the case of a lift. Got it, students? So these are the common forces what we will talk in the mechanics. Okay. Let us take up the second part of the chapter, that is friction. Now, let us consider an object here on this surface. Let us say the mass of this object is m. So the weight is going to act downward. That weight is equal to m into g. How the normal reaction is going to act? Normal reaction is going to act vertically upward. That is n equals to mg. Now, if I apply the force, this is called the applied force. This is the applied force. Because of this applied force, the body will start moving. The body will start moving in this direction. But continuously, this body will not move on this horizontal surface. Why continuously the body will not move on the horizontal surface? Because when this body is in contact with horizontal surface, there will be one opposing force is going to act. Because of this opposing force, that body is coming to rest. This opposing force is coming to rest when the body is going to move forward. So this opposing force, which is responsible to stop the body, this opposing force, we call it as what? A frictional force, or simply we can call it as friction. Simply we can call it as what? The friction. And please remember, students, this friction is coming into picture only whenever there is a two surfaces in contact. If the two surfaces are in contact, then whatever the opposing force is there, what is that opposing force? That opposing force is called the frictional force. So frictional force is the opposing force, which always acts opposite to which force? Applied force. Also remember, this frictional force, no doubt, it depends on the nature of the surface. Frictional force depends on what? The nature of the surface. And this frictional force is directly proportional to the normal reaction. If normal reaction is more, definitely you have to apply more force to move the body. If normal reaction is more, you have to apply more force to move the body, isn't it? So force is directly proportional to the normal reaction. If more force is moving the object means, definitely to stop that object, to stop that body, you have to give more opposing force. So clearly you can tell the frictional force is more. Frictional force is more. So you can conclude normal reaction and the frictional force will directly proportional. So frictional force is directly proportional to the normal reaction. To remove this proportionality constant, we are putting a constant like mu into n. This mu is a constant called coefficient of friction. What is this? Sorry, students. What is this mu called? Mu is a constant called the coefficient of friction. Can you tell me the formula for the coefficient of friction mu? It is nothing but F by N, right? Can you define what is the coefficient of friction? Can you tell me what is the definition for the mu? It is the ratio of what and what. You just tell me that. It is the ratio of the frictional force to the normal reaction, no? How do you define the coefficient of friction?
Ratio of friction by
Ratio of the frictional force to the normal reaction. Please remember, there will be no unit. There will be no unit for the coefficient of friction, because in the numerator we have frictional force Newton. In the denominator we have a normal reaction Newton. So both Newton will get cancelled out. So there will be no unit for the coefficient of friction. So coefficient of friction is denoted with the symbol mu, that is defined as the ratio of frictional force to the normal reaction. Types of friction. Types of friction. One is called the static friction. What is the meaning of this static friction? This static friction is denoted by the symbol Fs. Static friction is denoted by the symbol Fs. Suppose if I considered a body here on this surface, the body is at rest. Even the body is at rest on this surface, there is a opposing force. This opposing force is called the static friction. So the static friction will come into picture only when the two surfaces are at rest. If a body is at rest, then there is an opposing force. That opposing force is called as what, students? Static friction. Now let us take one example to understand the static friction in a better way. There is an object here where the weight is 10 Newton. So what is the normal reaction? 10 Newton. If I apply the force of 8 Newton, will the body move?
No, sir.
The body will not move because the weight is 10 Newton, but I am applying only 8 Newton. The body is not moving because there is an opposing force here. What is this opposing force called? Static friction. Now, instead of 8 Newton, if I apply 10 Newton, what happens?
Will not move, sir.
The body will not move, but it is ready to move, no? It start to move. Even if I apply 11 Newton, now the body is in. If I apply 11 Newton, the body will move, right?
Yes, sir.
So this 10 Newton is called the maximum static friction. So this is the maximum static friction. At this friction, the body starts to move. The body starts to move. At which friction the body starts to move, that friction is called maximum static friction. That maximum static friction is called the limiting friction. So what is limiting friction? Limiting friction is the one at which the body will just start to move. It slides to move. That is called the limiting friction. Now, when the body is in motion now the body is in motion here. The body is moving aram se here on the surface. When the body start moving, still there is an opposing force. Still there is an opposing force here also. This type of opposing force is called kinetic friction. What is kinetic friction, students? What is kinetic friction? Kinetic friction is the opposing force when the body moves over the surface of the other. When one body moves over the surface of the other body, over the surface of other body. When one body moves over the surface of the other body, that is called the kinetic friction. That is denoted by the symbol Fk. So what is kinetic friction? It is the opposing force between the two surfaces when one body moves over the surface of the other body. Can you tell me the static friction formula? Fs is equal to mu s into N. Can you tell me the kinetic friction formula?
Fk is equal to mu k n.
Very good. Mu k into N. Okay. Can you tell me the third type of friction?
Dynamic friction.
Dynamic is nothing but kinetic.
Rolling friction.
Yeah, rolling friction. This is called the rolling friction. So when the rolling friction comes into picture, students, if I say the body is rolling, then there will be an opposing force. What is that opposing force called?
Rolling friction.
Rolling friction. So that rolling friction Fr is equal to what? Mu R into N. Mu R into N. Please remember, students, static friction is more than the kinetic friction. Kinetic friction is more than the rolling friction. Static friction is more than the kinetic friction. Kinetic friction is more than the rolling friction. So which friction is very less? Rolling friction. Because of this reason only, if the heavy body is there like cylinder, usually we will roll the body, we will roll the cylinder. So it is easy to move because of less opposing force, because of less rolling friction. What are the advantages of the friction? What are the advantages of the friction? We can write it on the paper board. We can walk, climb. All these are the advantages. Similarly, there is a disadvantages also. What are the disadvantages?
Causes wear and tear of the machinery parts, sir.
So efficiency will be less, right? So there will be a wear and tear of the machinery parts. Because of that reason, only the efficiency will become less. After using some days, it becomes less efficiency. So in order to avoid this, we have to reduce the friction, isn't it? So name the methods to reduce the friction. You can convert all friction to what type of friction?
Static friction.
No. Static friction is more, no. You have to convert all the friction to rolling friction because rolling friction is less. And you have to polish the surface. You have to use the ball bearings to reduce the friction. So these are the methods where we are using to reduce the friction. Rolling, polish, ball bearings. Okay. Suppose if I considered a surface here, on the surface, if I place it a object, this is the weight which is going to act downward. This is the normal reaction N. This is the applied force F. There is a frictional force here, small f. Now, between the normal reaction and the frictional force, there is a resultant somewhere here. This resultant and the normal make some angle. This angle is called theta. This theta is called the angle of friction. What is theta called? Angle of friction. So what is angle of friction? Angle made by what and what? Angle made by what and what? Resultant of the normal reaction and the frictional force with the normal reaction. Angle made by the resultant of the frictional force and the normal reaction made with the normal reaction. This angle theta is called the angle of friction. Suppose if I considered a inclined plane, let us say denote that angle of inclination is alpha. For this angle of inclination alpha, if I place the object at the top of the inclined plane, then this starts sliding down. It starts sliding down. It is going to slide down at one particular angle alpha. That is called as the angle of repose. What is that called?
Angle of repose.
Angle of repose. So what is angle of repose? Angle of repose is the angle of the inclination at which the body will just slide down. That is called the angle of repose. Please remember, this theta and alpha are equal. Angle of friction and angle of repose are equal. Or equal. Yeah. Now, let me take the expression for safe speed of a vehicle on a level road. On a level road. Suppose if the particle, if the vehicle is taking a turn on the level road, what is the maximum safe speed of the vehicle? Let us say there is a level road. There is a level road here. Now, on the level road, there is a vehicle. There is a vehicle. The normal reaction of the vehicle is acting upward. What is the downward weight? mg. Now, there is an opposing force between these two surfaces. What is that opposing force called? Frictional force. Now, if I say this vehicle is taking a turn on this level road now. On this level road, it is taking a turn. It is taking a curved path. While taking the curved path, there will be a centripetal force is going to act towards the center. What is that centripetal force formula? V squared by R is the centripetal acceleration. Correct, Alva? Centripetal acceleration is V squared by R. So what is the centripetal force? M into A. So it becomes mv squared by R. This centripetal force should be balanced by some force. Otherwise, it will skid. So which force is balancing that? Which force is balancing that? The frictional force. The frictional force. Fs. So this frictional force Fs must be more, less than or equal to the mu s into n. This should get balanced with mv squared by r, which is less than or equal to mu s into n. What is normal reaction formula? What is normal reaction? M into G. So M and N will get cancelled out. V squared be less than or equal to mu s r into G. Do the cross multiplication. So what is V from this equation? Root of mu s r G. So what is the maximum safe speed of the vehicle? What is the maximum safe speed of the vehicle? Root of mu s r into G. Suppose if any vehicle is moving more than this, if any vehicle which is moving more than this, that vehicle is going to get skid. The vehicle is going to get skid if it is moving more than root of mu s r G. And one more thing you have to notice, students, here. This safe speed does not depend on mass. I mean to say that for cycle, for a truck, for both the vehicle, the safe speed will be same. So safe speed not depend on mass. For the irrespective of the mass, the safe speed of the vehicle will remain same. This is called the maximum safe speed of the vehicle on a level road, students. But this is not that much important for your board exam. The next derivation, this is very, very important for 5 mark. This is one of the most important question and frequently asked derivation. Derive an expression for maximum safe speed of a vehicle on banked road. Maximum safe speed of a vehicle on a banked road. So what is banked road? Here, outer edge of the road is raised with respect to inner edge. Outer edge of the road is raised with respect to inner edge. Inner edge. Students, here you have to be very careful while writing the diagram. If you understand the diagram, half of the headache is cleared. Okay. So let us understand the concept clearly here. Let us say this is inner edge. This is the outer edge. This outer edge of the road is raised by what angle? By an angle theta. By an angle theta. Let us say there is a vehicle here. There is a vehicle here. There is a vehicle here. How the weight of the vehicle is going to act? Downward, mg. The normal reaction should be act perpendicular to the surface. So this is normal reaction. It is not vertically upward, students. Why it is not vertically upwards? Because the road is inclined. This is inclined by an angle theta. So normal reaction can't be vertically upward. It is also inclined. So normal reaction is going to act like this. If the vehicle starts moving upward with some force F, opposite to that, there will be a frictional force, isn't it? What is that frictional force is equal to? F. What is that frictional force is equal to? F.
F.
Yeah. Now, can you tell me, we can resolve this n into two components? This is vertical component. This is horizontal component. If this is theta, y-axis is also tilted by theta, right? If I say this is horizontal and this is vertical. If I rotate this horizontal by theta, then this vertical also tilted by what? Theta. So if this is theta, then this component will be n cos theta and this component will be n sin theta. So we have resolved n into two components. One is n cos theta, the another one is n sin theta. Similarly, you can resolve this f into two components. One is downward, f sin theta. The another one is horizontal here, that is f cos theta. Because if this is theta, this is also theta because of alternate angle. So because of this alternate angle, F cos theta will act towards the left side. F sin theta is going to act in the downward direction. Downward direction. Now, please tell me the equations here. Now, upward force N cos theta should be balanced with F sin theta plus mg. If I shift this F sin theta to this side, it becomes N cos theta minus F sin theta is equal to m into g. N cos theta minus F can be taken as mu into N sin theta is equal to m into g. If you take out n common, what happens? If you take out n common, what happens? Cos theta minus mu sin theta is equal to mg. You can call this equation as 1. Now, what are the other two forces, students? Other two forces is n sin theta plus f cos theta, which is acting towards the left side. That force should be balanced with the centripetal force. Please remember, that is mv squared by r. Upward force n cos theta is balanced with f sin theta plus mg. Similarly, the left side force f cos theta and n sin theta should balance with centripetal force, that is mv squared by r. So I will keep n sin theta as it is. What is f? Mu n cos theta equals to mv squared by r. Take out n common. Sin theta plus mu cos theta is equal to mv squared by r. You can call this equation as 2. Now you can divide equation 2 divided by equation 1. What happens if I divide equation 1 by 2? This n and n will get cancelled out, isn't it? So you will left out with sin theta plus mu cos theta divided by cos theta minus mu sin theta, which is equal to, what about the RHS term? M and M will get cancelled out. So I'm going to balance with V squared by R into G. V squared divided by R into G. Now, I will take out sin theta common. Instead of sin, shall we go with cos? Take out cos theta common in the numerator. But in the first term only, we don't have that cos theta. So can I take that as sin theta by cos theta? Whatever the term you are taking, if that term is not there, you have to write that in the denominator. So if I take out the cos theta as common term, it will become sin theta by cos theta plus mu. Similarly, in the denominator also you take out cos theta common, then it will be 1 minus mu. Cos theta is not there in the denominator, so you take it as cos theta, which is equal to v squared by rg. So this cos theta will get cancelled out. So sin theta by cos theta will be tan theta plus mu, whole thing divided by 1 minus mu into tan theta, which is equal to v squared by rg. If I cross multiply rg, it will be v squared. It is tan theta plus mu, whole thing divided by 1 minus mu tan theta into rg. If I want only v, if I want to remove that square, I can write it as root of tan theta plus mu, whole thing divided by 1 minus mu tan theta into rg. So this is the maximum safe speed. This is the maximum safe speed of the vehicle on a banked road. So what is the maximum safe speed of the vehicle on a banked road? Root of tan theta plus mu, whole thing divided by 1 minus mu tan theta into rg. Students, you can notice here, if it is not a banked road, if it is not a banked road, then what will happen? Theta will become 0, no. If it is not banked road, then theta will become 0. So if theta becomes 0, what happens to tan 0 here? 0. So 0 plus mu will be mu. Denominator you will get 1 because the second term will get vanish out. So mu into rg, mu rg. So even if you put theta equals to 0 degree here, you will get the same back. You will get the same formula here. That is mu sr into g. If you just put theta equals to 0 degree. So this is the maximum safe speed of the vehicle on the level road. Any doubts? So this is the concept of the Newton's laws of motion, students. So this completes both inertial part and the frictional part. Any doubts you have, you can raise the questions.
Excuse me, sir.
Yeah.
Sir, how is n sin theta plus s cos theta equal to the centripetal?
No. That is what? If the vehicle is there, this n cos theta, which is going to act upward, is going to be balanced with a downward force. So the vehicle will not move up and down. Suppose if the vehicle is taking a turn, the passenger who are sitting inside the car, the body of the passenger will lean towards the center. The body will bend towards the center, but the body will not fall towards the center. That is pulled back. That is pulled back with the centripetal force. If centripetal force is not balancing these two, if the centripetal force is not balancing this, then the body will skid and the body will bend towards the center. It will fall inside the center. To balance that, there is one force which is acting towards the center of the motion, that is called centripetal force. So that centripetal force should balance with these two, F cos theta and N sin theta. Got it?
Yes.
Any doubts, students?